Hello again. So, you asked, what is IBM doing about generative AI? Right? Generative AI is all the rage. And while you've noted to me that you've recognized IBM as a leader in AI for many years, and I know that you're using some of our technologies for machine learning and for more traditional AI, but platforms from OpenAI have garnered so much attention that it seemed as if perhaps IBM didn't have an entry point into this particular market. Well, that's of course not true. With the introduction of Watson X, the watsonx.ai component is available, which makes it possible for enterprises like yours to train, validate, tune, and deploy AI models. And this, of course, includes both traditional and generative AI. So you can leverage your existing traditional AI investment as well as exploit all the innovations and potential of generative AI built on foundation models to bring advanced automation and AI-infused applications to reduce cost, improve efficiency, scale, and accelerate the impact of AI across the organization. So I know you have a few specific generative AI use cases in mind. Specifically, you'd like to see some text generation capability fit for the enterprise, as well as some summarization capability. And I'm going to show you some examples of each. And while doing so, I'm also going to walk you through a portion of the watsonx.ai user experience and show you the impacts that can be had on performance of these models made available to you through watsonx.ai, through prompt engineering and manipulation of the parameters of the model. Okay, so now we've entered the watsonx.ai console, and you can very clearly see here that watsonx.ai is not only about generative AI capabilities. We do have the option to enter the prompt lab at this time, and we can, of course, work with different models, test some prompts. We could do some zero-shot, one-shot, or few-shot prompting. And we can also, of course, change the parameters to control how conservative or creative the generative AI model will be. We won't focus on the rest of this in today's session, but just note that watsonx.ai as a platform is a complete end-to-end AI platform, meaning not only can we work with generative AI, but we can also, of course, work with traditional AI and machine learning models. So we can work with those in Python or R notebooks. We can also use visual modeling capabilities built into the platform. So we could generate those models in a drag and drop fashion. We also, of course, have auto AI that you can leverage to automatically build machine learning models. And there's also a facility here for loading data and preparing it using our data refinery for later consumption in our AI models. And we also see a list of projects that we're working on, and we can see links here to our deployment spaces. This, of course, is where we can place our assets to create, run, and manage our deployments. And there's, of course, also a full complement of samples here to guide us on our journey towards creating artificial intelligence models. Again, the focus of today's demo is to really look at the capabilities afforded to you in the prompt lab. And these capabilities will allow you to work with prompts and different foundation models. So let's create a brand new project. And we'll start working in the prompt lab. The prompt lab provides a number of capabilities. We're only going to go over a few of them today. So here you can see we have a number of sample prompts that we can leverage in our journey to learn the capabilities of our prompt lab. We store a list here of saved prompts that have been executed in the past. As you can see, this is a brand new environment, so we have no saved prompts yet. And then similar to saved prompts, we of course retain a history of prompts that have been executed in the past. Up here, you'll note that watsonx.ai provides AI guardrails. You turn this on when you want to prevent potential harmful input and output text, things like hate, abusive, or prejudiced wordings. Over here, you see we have the ability to toggle between structured prompts or free-form prompt editors. Structured prompts is the default. It provides guidelines for the prompt and is, of course, recommended for beginners. And then, of course, experienced users may opt to try the free-form prompting. Here you can see we can change to different foundation models. And you'll note there are a number here that are included for our use. some of them provided by IBM, some of them verified by IBM, but residing on Hugging Face. Note here an optional parameter where we allow users to provide an instruction which can become part of the prompt. Here we have the option to provide a sample input, and here is where we would provide a sample output corresponding to the sample input. Foundation models can oftentimes be thought of as probability machines. They generate their output based on what might be the best extension of the given input prompt. And using these sample inputs and sample outputs, the user can teach a foundation model, and these sample inputs and outputs are referred to as a shot. These teach the model how best to respond to a query or a prompt. If you forego using a shot, this is called zero-shot prompting. We're using this interface I'm showing here. We can do one-shot prompting, right? A single input, single output, sample provided. And we, of course, also provide the ability to do few-shot prompting, where you might do 2, 3, 4 input and output samples. One-shot or few-shot prompting makes it far easier to teach a model how to optimally respond. And then the try section is where you actually enter your prompt or query into the foundation model. Here's where the generated output from a foundation model will be displayed. And once we enter all of our criteria, we would use the Generate button for the model to generate its output. Let's take a look at some of the sample prompts here. And you can see that there's a number of samples here classified by their use case, right? So we have summarization, classification, generation, extraction, question answering, code. Let's take a look at one of the generation use cases, marketing email generation. Okay, so we can immediately see that the FLAN T5 extra large 11 billion was automatically selected. This is because watsonx.ai selects the model that is most likely to provide the best performance. This selection is not a guarantee of performance, so we will actually explore different models just to see how they complete the task differently. Now we can see here, this particular example, the prompt is asking the foundation model to generate a 5-sentence marketing message based on several characteristics. You can see the characteristics are company's Golden Bank, offers to include several different criteria, the tone should be informative, the response we're requesting is that the recipient of the email click a link, and the end date will be July 15th. So as this sample is complete, we can just click Generate. And we can see that the model has returned a result. There's just one interesting line here. It says, you can now monitor all of your Golden Bank accounts from home. Notice that was not part of the criteria here in the details section. So that could have been generated based on similar offers from other banks. And of course, Golden Bank is also a real financial institution, so this may be pulling from other details related to Golden Bank. So this is a good example of very good results from zero-shot prompting. And also worth noting are the details shown here. We can see the execution time. We can see the number of tokens consumed was 63. The number of tokens generated was 81. And importantly, we should note that we've consumed 144 out of 4,096 tokens. This 4,096 limit value is dependent on the model, and these limits may be raised in the future, but in any case, this limit is the current limit for the FLAN T5 XXL 11B model. Now let's run this scenario on a different foundation model. We'll use this encoder decoder, the FLAN UL2 20B, 20B referring to 20 billion parameters. And we can see the model card here. This is obviously a third-party model, not an IBM model. And we can see how it was trained. And if it has already been tuned, we could see that here as well. So having just changed the model, let's generate again. Now this is an interesting completion using a different foundation model. And while most of the email is similar to the output of the previous model, this one shows a very common flaw of generative AI. We have a hallucination here. You'll note that our input criteria does not include a phone number, and yet the output includes a phone number. The model has completely made that up. And this is, of course, a simple example of where a larger foundation model may oftentimes perform worse than a smaller one. Okay, so we've quickly seen that given a list of characteristics, different models will generate different marketing emails, potentially with various degrees of hallucination. Let's look at the same generation sample, and you can see it's returned back to leveraging the FLAN T5 XXL11B model. And if we hit generate, we should get the same result we've seen earlier. Let's add any additional information. And we can see here that it no longer includes the line. You can now monitor all of your Golden Bank accounts from home. If I switch back to the FLAN UL2 model, now with the additional detail, you can see that we've eliminated the hallucination on the phone number. But what we do see in this particular case is that the model still could not resist inventing a website. It's hallucinated a non-existent website. So this shows that the FLAN UL220B tends to be a bit more creative than the FLAN T5. So let's try something a little bit more explicit. Not make up any phone number or website. So we can see our made-up website is gone, but there's still a hallucination. This larger model was likely trained with finance data, and that made it determine that an account with a minimum balance of $500 is a high probability and added it to its output. Basically, the larger the model, the more creative the completion tends to be. And because of this creativity, we should try something very explicit. Let's try again. See if we can get rid of that website. So this is the proper email with no hallucination. Try a different model. This is an auto-regressive language model. And we can see that this model's generated email isn't even close. Talks about all sorts of nonsense. It didn't even complete its output, and it really only stopped because there's a limit to the number of output tokens. But watch what happens if I change this line. And we can see here that it is closer to an email that talks about some of the criteria here in the details section, but it's an awfully creative model that needs further reining in. Multiple hallucinations here with made-up websites, lots of misspellings throughout the results, and it's all because the Llama 2 70B chat model is huge. It can be quite unpredictable. So what have we learned? Well, we've learned that even with zero-shot prompting, it is possible with the right model to modify a prompt and get a very good response from the foundation models. Larger, more creative models oftentimes require more explicit instructions. Certain models haven't been optimized in the same ways and are better for certain use cases. And we've learned that larger models are not necessarily smarter, but they can often be more creative. So overall, careful selection of your prompts is important, and careful selection of your foundational model is important. Let's create a new session here. And let's stick with the same sample we've been working with, so we can this time experiment with the impact of changing parameters. Rather than use the FLAN T5, let's use the FLAN UL2 model, which we know hallucinates. Let's add our additional prompt here, as we did earlier. And we know that it still further hallucinates at this point, where it's inventing a website. So let's look at some of the inference parameters we can actually modify. The greedy versus sampling decoding is how the model chooses the tokens for output. When it's greedy, The model selects the highest probability tokens at every step of decoding, and the model is less creative in that mode. And in the sampling mode, the model tends to be more creative and random, but there is a larger risk that the output may be nonsensical. We can access temperature. It's a floating point number ranging from 0.0, causes the model to operate in the same manner as if greedy decoding was selected, and 2.0, which is maximum creativity. The default value is typically 0.7, but in this case it's set to 0.8, which means it's allowed a bit more creativity. Here, top P, nucleus sampling, floating point number from 0.0 to 1.0. Top P decides whether the model will always pick the most likely outcome or allow more randomness for the next few words. This is all about scoring the probability of the next choice. It's important to keep in mind that the higher the value of top P, the larger the candidate list of words, and so the more random the output would be. So, at high values of top P, the outcome tends to be more creative. Top K is an integer with a range from 1 to 100, and top K does not look at probability of words. Instead, the model simply chooses from the top K most likely words to be the output. So the higher the value of top K, the more random the outcome would be. Random seed. This is an interesting one. This is an integer in the range from 1 to 4,294,967,295. If you don't change the random seed, you should always get back the same results. The point is, if you change the random seed, you should get a different result. Repetition penalty is a value between 1 and 2, where 1 allows repetition and 2 prohibits it. This is intended to counteract a model's tendency to repeat the prompt text verbatim or be stuck in a loop in generating the same output. Stop sequences of characters, and it could be things like text or carriage returns. And when the model encounters one of these sequences, it will stop generating output. Then we have min tokens and max tokens. Min tokens is an integer that specifies the minimum number of tokens in the model's output. Max tokens is an integer that specifies the maximum number of tokens in the model's output. Now, we've seen here in our result that the result is a bit creative. So let's first try changing the temperature from 0.8 to something less creative. We'll try 0.4. So here we no longer have the made-up website, and we can see that lowering the temperature has made the model less creative, and in this case, stopped the hallucination. Let's set our temperature back to 0.8, just so we can tweak a different parameter. Let's change top P from 1 to 0.5. Setting means that the model will consider the top set of tokens whose sum of probabilities adds up to greater than 0.5. So we're throwing away the low probability tokens. And again, this is the kind of email that we can send. No hallucinations included. Let's set this back to 1. And let's take top K, cut it in half, 25. In this case, having the value of top K to 25 does not have the same kind of effect as having top P. The output is still hallucinating with the URL. Let's try dropping it a bit more. Still hallucinating. Here we go, we reduced the inclusion of a URL, but it still says click here. It doesn't make any sense in this case. Here we go. So we had to lower top K significantly in order to get it to stop hallucinating in this particular case. Now it might look here as if varying the values of top P or top K seem to have either great effect or no effect, but you have to remember that a model determines how many possible next tokens and what the probabilities will vary. And generally, there are a lot of possible tokens. So depending on how a model is designed and trained, varying top K or top P will have very different effects. So it's important to have both of these controls in our toolbox. Okay, so we've seen an example here of some of the generation capabilities that we can leverage within the prompt lab, and we've seen how model selection is particularly important for accomplishing certain tasks. We've seen how we can tune the prompt a bit to get better results and how that's impacted by model selection. And we've seen how modifying the various model parameters can impact the results as well. Why don't we take a look at your other use case? You mentioned that it was important also to cover summarization, and this time let's not use any of the sample prompts that we have available. We'll go ahead and create a new session. And instead of structured, let's use the freeform interface. This is really more for demonstration purposes. We could do it through a structured interface as well, but I'd like to show you how this is done in the freeform interface. There's no structural guide. It almost comes down to personal preference. And you should note that in freeform mode, the default parameters take on a bit of a different look, and this is because we're not working with a prompt sample. In particular, note that the min token's value is 0, which means, of course, the output can potentially be empty. And the max tokens is set to 20. And this is going to give us a particularly small output because there's so few tokens allowed in the generated output. So let's change that default instead to 100. And we're going to work with greedy decoding. And in this case, we will be using the FLAN UL220B model. So I have some sample text here I'm going to put into the input, and you'll note the following paragraph is a consumer complaint, and the instruction is read the following paragraph and list all of the issues. So we then have a paragraph of text, and we have a bit of an instruction here that says the list of issues is as follows. I click generate. Okay, so a couple things to note here. It did not output a list, just repeated everything that I input, and it of course got cut off because it reached the max tokens amount. So this is not a useful result. Let's remove everything that was just generated. Let's switch to the FLAN T5 model. Try again. And we can see the exact same output. It appears that both FLAN models, without adding additional prompts or changing the parameters, seem to have misunderstood what it means to list the issues, and it simply just repeated what it was already told. Now, in particular, the FLAN models respond well when prompted with a number indicating that we want a list. So now the output is a list, even though it's simply still repeating the input that it was given. If I run it through a more fit-for-purpose model, and we can see that this MPT7B instruct2 model correctly interpreted the request as providing a list. Let's remove the result. And let's actually try yet another model. Okay, so that was just a quick glimpse into using Prompt Lab in freeform mode. And we again saw that different models handle output requirements differently. Notably, the FLAN models we looked at are better with text output with zero-shot prompting, and we saw that we can guide the output if we update the prompt with a hint, such as suggesting return me a list. Other models, such as the MPT7B Instruct2, are better able to understand the concept of a list output without necessarily needing additional instructions. Again, we saw that the size of the model is not necessarily the most important criteria, and we saw here that the model with the smallest number of parameters provided the best performance. And that's because the MPT7B Instruct2 model was trained by IBM to follow a user's instructions, and so it was better able to understand the prompts instructing the model to output in a particular list format. So we've done zero-shot prompting. Let's do a little bit of experimentation now with one-shot prompting. We're going to stick with structured mode. I'm going to use greedy. I think we'll increase our max tokens to something larger, like 100. I want to use the FLAN UL220B model. And first, let's look at the output of this with zero-shot prompting. So I have some sample input text. Here we go. Take a look at the output. And this is clearly not the output we were looking for. The model seems to have taken the first part of the prompt and simply read the content, determined it was about credit cards, and in this case, the model performed as though this was a classification instead of a summarization. So let's give it a one-shot example. Okay, and we start by saying the following paragraph is a consumer complaint. Provide a list of the possible subject areas that the complaint may be about, and then the text of the actual complaint. And when doing one-shot prompting, you need to put in input, but also a sample output. Here's my sample output. And now we can see with the one shot, the output this time is properly formatted as a list of customer complaint issues. So we performed a one-shot prompting, and we saw how providing an input example and an output example can help the model respond in a more desirable way. So there's plenty of other things we can do with the prompt lab. So if we chose, we could certainly save our work as a prompt template, or if we were making changes over time, we could change it as a prompt session. And then we could, of course, review that template and then that prompt session to see where we modified the prompts and the model parameters and with what settings we got the best results. There's valuable insights to be gained from reviewing our past work. We also can save our work in the form of a notebook so that we can further integrate our work via code with external applications. I'm not going to take you through any of that for this particular demo. And it also should, of course, be noted that with the various models available to us, we also can work with different types of data. In particular, it's worth highlighting that through the prompt lab, we can actually use a model like StarCoder to generate code in a very similar manner to how we just generated text using zero-shot, one-shot, or few-shot prompting. So that's a significant capability of the platform. And I spoke earlier about watsonx.ai being an end-to-end AI and machine learning platform where you can perform tasks working with generative AI and foundation models, and you can do that as we saw with the prompt lab, and further tune with the tuning studio. And we can further work with more traditional AI and machine learning, leveraging the additional capabilities of watsonx.ai. For demonstrations today, I highlighted for you a simple generation use case where we generated text, in this case using some of the sample projects, but we used them to generate emails, and I was able to show you the impact of model selection and modification of parameters of the model, and some light prompt engineering to expose the potential for hallucination and also ways of working around that to get the best results. You also asked about summarization, so I showed you some examples of summarization, in our case, creating lists to summarize the text presented. And again, use that as an opportunity to show you the freeform mode, additional tweaking of model parameters, and also zero-shot and one-shot prompting. Of course, few-shot prompting has the potential to provide even better results than one-shot prompting. Now, of course, the platform is capable of handling many other use cases, but that's outside the scope of today's discussion. I hope that I highlighted today the importance of evaluating different models and their strengths and weaknesses when used for different tasks, and the power that's present with simple prompt engineering, even without using more advanced prompt tuning techniques. And I demonstrated to you that the platform includes sample models and prompt libraries to help you quickly ramp up on your prompt engineering skills. And you saw that watsonx.ai includes a growing number of open source as well as IBM sourced models. And you should know that one thing that sets IBM apart is that our models are carefully chosen with the best combination of both size and performance. And any model that makes it into the platform is fully vetted by IBM to remove bias, profanity, non-truths, and personal information. Our models and our chosen open source models are based on trusted data. So what should we do next time? I suggest leveraging the free trial as a first step. And after that, I think we should follow up with a meeting to discuss what you found important, what you might have additional questions on, and how we can next proceed to the proof of concept so that we can put your data and your very specific use cases to the test on watsonx.ai. I look forward to our next chat. Thanks.